Hey Richmond, we're starting a little bit early. We're not going to actually start until 1, but somebody just let me know if we got a good feed going. Okay.
That's not gonna work.
That's what I just did.
It's called Sightsource and Power, it looks like.
YouTube doesn't show me that. Is it a private channel that needs invitation?
Let's see.
Sightsource.
Looks like there are 14 subscribers, so somebody must have found it.
Oh, now I find it.
Okay.
Now you should see 15.
Yes. And there you are.
And the site sources, YouTube's messed up. Look at this. Subscribe 15, 14 subscribers. Right. Good math.
Yeah.
No problem.
You just have to like engage with specific requests that were delivered why then it gets what's in the means. So eventually it only shows you if you had some kind of information. It only shows you like
I have a question for you.
search for some.
Okay. So I'm doing. Let's see, that's my diagram. Query number 4. Venezuela's in hard times. We need list of managers, location, store information for the 3 countries.
Country, city, so we got store. So it looks like you got most of the stuff you need.
I don't get how to do the list managers, and so I've been looking.
Managers. So manager, I think, is under. They don't call it the manager table. Probably staff.
Yeah. So I have staff here.
Yeah.
And I want to connect it through this, but I'm not sure how to.
Right there it is. Store ID.
Yep. I'm not sure.
Manager staff ID.
Right. How to identify which one is a manager and which one is not.
Just use that one instead of that one. So the staff belong to a store, but there's a special column dedicated to managers. So I would join as this being the child and that being the parent.
This being the child, the manager staff?
Yep. Because that's where the foreign key is, pointing to that.
Okay, and then staff ID be the prime. That's what I figured.
Yeah, and I would remove the other, well, not in your diagram, but your other joins, don't need them. You just need the one. And
So
even to get...
Don't I need the store information, though?
it depends on what the question was originally, how I posed it, but if you've got the store, you getting it through... How are you getting it? Address ID?
Yep, so I'm going from country to city ID
Yeah,
to
and then you get the
address.
manager. So you don't need to go that way. You can get manager through store.
Gotcha. And so I just need to put the manager ID. And
Yeah, manager staff ID, it should match a staff ID.
okay, cool. Thank you. And a Twix bar too. You went all
And a Twix, I just went for it. Living my dream.
left or right?
Left Twix or right Twix?
Left Twix or right Twix?
Oh, really? I didn't know that was a thing.
Yeah, it's a huge
It's like their marketing.
This is a big deal. This is a very big deal.
But now it's left. No.
That's the joke. You got right.
It's ironic.
You got the right.
Okay, bless you.
She's a right sider.
Welcome back from lunch. Let's do a brief review of SQL. Let's. I told you the other day that most SQL is select statements. inserts, updates, deletes, those are really an application developer's problem. Remember, we've got our DBA hat on. We don't care about inserts, updates, deletes. That's, by the time we look at things, our job as DBAs, database administrators, is to take care of the data and make sure that the indexes are running properly and the selects run well. Inserts, updates, deletes, yeah, you can add more data if you want, but that's part of the application. An application like Node.js or C# or Ruby or Elixir, they're going to have logic where users can type in a bunch of stuff, or you have those Raspberry Pis devices collecting data and it's storing records. You're going to have an application that does that, but we're not going to worry about it in the database for the most part. So I'm going to very, very briefly show you how to insert, update, delete, and then we're not going to talk about it much anymore. So and before anybody wants to furiously try to keep up with my typing, I encourage you to take notes, like on paper or just summary, but do not copy or attempt to copy the code I'm going to write, because I'm going to share it with you. You're wasting your time. And it's more important you write down the concepts. Take notes that are, okay, a select is always part of a query. Always. Okay, so select. And just like a little note to yourself, oh, this is the first keyword in a SQL select statement. From, you always have one of those too in a real query. Where, you may or may not have one if you want to filter the rows. So I'm going to go through that, the anatomy of a select, and then we're going to build one progressively more complex. We'll start with a straight table select, then we're going to have an inner join, then we're going to have a left join, a right join, we'll do a cross join, we'll do a where clause, we'll do group by, we'll do a derived table, we'll do correlated subqueries. A lot of those things, half the stuff, you probably didn't even know what it is. So we're about to find out. Step by step though. So in your notes, you're going to be taking notes like, what is a correlated subquery? Oh, scribble down something that makes sense to yourself. But don't try to keep up with the code. I'm going to share the code. So, Sakila. Did anybody have a guess about why we went through the trouble of restoring this database?
So we'd all have the same data.
So we'd have the same data, but my ulterior motive was so that we didn't have to write a bunch of inserts, updates, and deletes. Inserts, primarily, to populate the data. Because once we've restored it, oh, there's another thing. On Friday, for those of you in Winston-Salem, your minds were shielded from the corruption of having to use SQL Server Management Studio to back up and restore a database. Unfortunately, Richmond, I couldn't save your eyes and ears from that. But let me show you why I did that. You can fiddle with the SQL Server Management Studio and do it the cumbersome way. Or, brand new query, no tricks here. I've got a Sakila database. I've also got a Classmates database. Somebody help me out. What do you think the statement might be to back up a database?
Backup.
Backup. Database. What's your database name? Let's call it Sakila. This is where it's a little bit funky. You say, where do you want to put it? What do you think goes there? A path. I'm just naming it something after the day and time when I took the backup. Anything else? Nope. It's that simple. Well, I should probably give it an extension. BAK is what's generated for you if you use the user interface, but you can just name it whatever you want. It's really the contents of the file that matters. So with that, and you have to have this path. So cdb backup, let's go make sure that we have that. The point here is that don't bog yourself down with a user interface if the user interface is getting in your way. Because all the user interface is doing in SQL Server Management Studio, it's writing scripts. So I'm going to run this. Bang. Done. It even tells you a little bit of information about what happened. 0.129 seconds. Don't let the user interface slow you down and take 20 minutes. So let's do... You don't believe me? Watch this. I'm going to say right-click, design. You don't have to do this with me. I'm just pointing out what the user interface is doing. So if I wanted to do that, I'm going to say save Actually, I think I've turned off the prompt. Yeah. Let me do that again. There's a way you can say, show me the script that you're about to run. And I probably should have looked it up before I tried to demo it. Really all this is doing is it's writing a script, and there's a little setting in Tools that says, allow me to review the SQL script you're about to run before you execute the changes that I specified here. So really what you're doing here is you are a user to SQL Server Management Studio. You don't have to be a user. You're a developer. You can write the code. So you can skip this step entirely. And let me see. Database engine query. Anyway, I will look it up at the break, and I will show you.
It says the database is there.
What's that?
For the internet, I think it's the database is there.
No, it's actually the change that I just specified. In this case, I was updating a column name. You can actually generate SQL, generate change script. There we go. So here. So it says, okay, we're going to have a transaction. We're going to call a special stored procedure called sp_rename that's going to rename it from updated to back to that. We're going to do it in 2 steps. And then we're going to change a table setting. So all of that happened automatically when I click Save. So the point is that everything you're doing in Management Studio, there's a script for. And all Management Studio is doing is it's generating and executing the script for you. So back up, that's all well and good, but how do you restore? Back to our thread of execution, trying to keep it single-threaded here. So if I get off track, it's like, Ali, focus, please. So backup database Sakila. What did that do? It created a file for us. So let's think about the real world. This file didn't exist about 10 minutes ago. So in the real world, how big is it? It's small. It's 12 megabytes. So if I wanted to restore that somewhere else, I would copy and paste this file. That's all I need. I've got what I need, throw it in my trunk. I'm going to go somewhere else, drop it off, take it out, put it on the disk at a known location. And then, so this is, I could restore it to the local server as a different name if I want. Why might I do that? Why might I restore a database to the same server it came from?
So you can alter it without damaging the initial database.
Yeah, it's like I have a complete copy, and that it's never going to change unless I change it. It's just sitting there waiting for me. So if you want to take a copy of something and give it to a developer to go off and run queries on and updates and deletes or test with, or if you wanted to have a QA environment or a test environment that looks exactly like production, take a backup of the production database and restore it as a different name. It sounds really complicated. Let's see the statement. What do you think it is? Restore database. This is where you can choose whatever name you want. This is the target name. So in this case, Sakila copy from disk is equal to, and I'm going to copy and paste. Since I didn't move it, you know, in the real world, I'd probably copy and paste this, put it on a different computer or whatever. I'd say that with recovery. Now, with recovery is important because that says, that's the whole statement. So up to there, you're with me probably. It's like restore database, yeah, I got to have the name of it, and then where is it? Yeah, there it is. This says sometimes you want to partially restore, and then you want to do something else. Let me get a peek into the mind of a database administrator. Your system crashes at 3:06 p.m. in the afternoon. You have full database backups from every night, which is what this thing is. That's a full database backup by default. You also have what's called log backups. So every 10 minutes, every 5 minutes, every transaction is logged. That's not a full database backup. That's, you can take the last full backup and then you can roll forward the transactions. Everything that happens in SQL Server is logged. Inserts, update, deletes. Selects aren't logged because it doesn't modify the data structure. Inserts, update, deletes are logged. The reason it does that is so that you can play that log back one transaction at a time and get to exactly that state. So I'm going through a long explanation, but I actually have a point here. So restore database. If I want to say, give me the entire last full database backup and restore it as it was at that point in time, that's all you need with recovery. If I wanted to restore and then I wanted to add, I want to play forward those transaction logs, you have to tell it, hold on a minute, I don't want you to make it active yet. With recovery means turn it on so all the users can start hitting it immediately. There's another couple options. Is if you want to do something special, like I want to restore it but keep everybody else out of it because I'm about to run a lot of transactions back in to get it back to 3:05 p.m. That's the power of good database backup plans. You can restore last night's full database backup, and then you can play forward the transaction logs up to 3:05. So even though the entire server crashed, you have lost 1 minute of data. And that's how you keep your job as a database administrator. Unfortunately, it's usually 2:30 in the morning when they call you, though. And that's why they get paid. That's the little secret. Database administrators don't do a whole lot of work. They're more of an insurance policy. Because when it goes down, you need to have a database administrator to get you back like that. And then it's all worthwhile. So, restore database. I'm going to do this, but this is not going to work because I've got to show you a little peek at something. A SQL Server database consists of, at minimum, 2 files. A data file, that's where all your table data lives. And I just told you a little bit about a log file. Log file is every transaction is logged. So it's like there's an insert, there's an update, there's a delete. And it keeps it in a certain sequence, in a certain proprietary format. All the log file contains is everything that's happened since the last backup. So, why does that matter? Because if I were to do this, I have Sakila already here. So there's going to be a file by the name of sakila.mdf, which is my data file, and I've got an LDF. Now I just took a backup, so the backup file wants to put the files back right there. In order to have a side-by-side copy, I've got to rename those things. There are only 2 files, so I know this is why database administrators say, no way, I'm just going to go back to the user interface. You're scaring me here. Bear with me. This is all you have to remember. If you have a foreign database, say somebody else's database, and you don't even know what the names of the files are. File list only. You can run that, and it'll tell you, oh, backup file, what's inside of you? What do you have? And it tells you the logical name, Sakila and Sakila_log. Those are the logical names of the files you need to restore. If your eyes are glazing over, you can completely forget about this and do this through the user interface. So you're not going to miss much. But if you want to learn how to do things in the real world and restore databases side by side, you don't have to call your database administrator. This is how you do it. Okay, so what have I done here? Why did I do this? I mean, now you're going crazy, Ali. It's like, I understood you up to here, but what's going on here? If that's Sakila.mdf, see where it wants to call it that. Now, let's go ahead and run it. Let's try to run it, and it's going to say, wait a minute, a bunch of nasty red error messages. It says, you already have one there. I can't overwrite it. So all I'm doing here is like, okay, restore it, but name it something else. You have to do this almost every time you restore. Because you take a backup of a database here, it wants to put it in the same path on the other server. What are the chances that the path on your target server looks exactly the way it is on your computer? Like 1%. So most of the time you got to tell it, oh, when you restore your data file, put it here. When you restore your log file, put it there. How do you do that? The move command. It says move the name of the logical file to, this is the path I want you to put it in. So if I do this, bang, done. So now we've got Sakila, and I've got a Sakila copy. And I've got 2 databases over here. Completely separate. They don't care about each other. They don't know about each other. Oh, why is it not up there? Because SQL Server Management Studio never refreshes automatically. There's my Sequila copy. It is a complete copy. Every piece of data, every piece of structure. If I had stored procedures, if I had anything defining their triggers, it's all inside that file. If you think, you know, Ollie, I'm going to do you one better. You're wasting our time. Why can't you just copy the MDF file and put it somewhere else? Because how does SQL Server run? As a Windows service. So watch what happens if I try to do this. It says you need administrator. Okay. Uh-oh. Can't be completed because it's open. Windows service is always running. So what's happening is the SQL Server service, the engine, always has it open. As long as your SQL Server is running, you're not going to be able to touch that. You can't change it, you can't modify it, nor would you want to, because you're trusting the SQL Server software to do that for you. Don't ever try to mess with your MDFs and LDFs directly unless you know exactly what you're doing. Okay, so I've backed up and restored. How do you get rid of an entire database, all tables, all rows, and all those tables?
Can you go over the restore one more time, just a bit more succinctly, so I have it?
See how dangerous that command is? Yes, I will go over that. Bang.
And tears also dropped it.
Yeah, so it's done. I mean, it looks like it's over here. Watch what happens if I try to... Let me go look at that. Let me do select. Uh-oh, it's gone. It does not exist. So, once again, SQL, it's going to trust you. No training wheels here. That's why database administrators have jobs. You make a mistake, you better have a backup. There's no little pop-up windows. It's as fast and as furious as you want to be. So, let's go back to backup and restore. So, up here, if I want to back this up, I'm saying backup database. Let's back up and restore another one. So I'm going to refresh this. Let's see what we actually have on here. So let's back up. Somebody tell me how to back up and restore classmates.
Backup database. Database name, what's the key classmates? 2 disks. And then the location of where you're backing it up to.
Do you make sure you have a capital C because it is a capital C in the database name?
SQL's not case sensitive, so no. It's fine. It's nice to name your file something that says, oh, this is the backup from that day. Because it could have multiple backups. You usually do. But, you know, that will work. We could actually call it this if we want, X. I'm going to run it. I've got a backup. I've got a new file over here, cdb backup, X. I have no clue about what's in it, nor does anybody else. So, hence, if you can even figure out that it's a backup file, you can do this to it. Restore file list only. That says, I don't want you to actually restore it. I want you to take a peek inside of that file and tell me what's in it. And it says, why do we do that? Because we need the logical names. We need these things to talk about when we move them around. Now, if that file didn't exist, if classmates.mdf and LDF didn't exist, or if you're restoring this to another server and it has cdb backup, cdb in it, okay. You don't have to do the move. The move just says, if you want to change this path or file name. That's why you do that. So, somebody help me out. How do I restore this X thing?
Restore database. Give it a name.
What do you want to call it?
X copy.
S16.
I like classmates too. That sounds classmates
Now that
too.
we know what it is.
From disk. Is it X?
No, classmates.
It is.
It is X. Because that's what we named the file.
Oh, okay,
It's just talking about the file there. We're missing one little thing on the ends.
yeah. Oh, dot. No, sorry.
With recovery. that says, I'm done, I don't have any special operations going on, I want you to actually make it live. Let people in. Now, if we do that, that's the right syntax. There's nothing wrong with that, but it's going to fail. And it'll tell you why. Derek was right. These red error messages, that's a good day. It tells you exactly what's going on. You see what it's trying to do. It's like, oh, I'm trying to restore MDF, and I've already got a file there. I'm not going to overwrite it for you because that's probably not what you meant to do. So how do we tell it? Move, and we're going to say, we could put it all in one line if you want. It's like HTML. It doesn't care about white space. So we're going to say move, and this is where we have to know the logical name. Classmates to. Remember how on the first day I said here are paths? You see them everywhere? Paths again. Is this a relative or an absolute path, by the way?
Absolute.
Absolute path. If I got the extension there wrong, would it work? Yeah, it'll work. It'll take whatever you give it, but the right extension is MDF. I think it stands for a Microsoft data file or something, and LDF is log data file or something like that. So now I run that, and I've got an extra comma on the end. Copy paste error. There we go. So now I have 2 copies of the Classmates database and everything inside of it, which was nothing. Okay. So, any other questions about backups and restores? That's something, a real-world skill that you will use. Okay. I will put that aside. Actually, so I won't forget later, I'm going to drop code as we go. There you go. So let's talk about SQL. Let's talk about Sequila. The reason we stored Sequila is because I didn't want to have to go generate a whole bunch of fake data. And Sequila is nice because it has a bunch of data inside of it. If you've successfully restored, as a matter of fact, if you have not successfully restored the Sequila database to SQL Server, raise your hand. Okay. Some of the docents, if one of you could go by at the break or now and just like help them get it restored, because we're going to be writing some queries. The way you can check out a database, this is, in the real world, how you deal with databases. About half the time, the databases you write queries against are not your own databases. Developers have come before you, they've created databases, and you're put on a project that says, oh, we need to add a feature for this application. Go write a query or store procedure that gets the data from this database that somebody else wrote. Do they give you any documentation? Sometimes. Do I ever read the documentation? No. Because the documentation is most likely going to be a bunch of lies, because it was written and then they kept changing things, and nobody went back to change the documentation. Where's the truth? It's in the tables. So, in SQL, here's how you reverse engineer a database. I restored this. I purposely didn't look at any of the documentation, and I started looking at it. Here's how you get into a database and figure out what it's doing. Take a look at the names of the tables, number 1. Take a look at the columns. If you see something that says _ID, it is probably going to be, and this one even tells you, it's a primary key. It's got a little key there. That little key backwards, I believe that means unique foreign key. That just means foreign key. So you got a foreign key to city ID, so you probably have a table named city, and there it is. Columns. Oh, and what do you know? You have a foreign key from city, so it's daisy-chained all the way to country. Okay? And it looks like country, you have a primary key, but you don't have anything else. You got a string field, and you've got a date time field. Let's take a little peek. How do you do that? Right-click, select top 1,000 rows. What do you know? We have some countries. What type of key is that? It's a primary key, but it's also named something else. Wow, you're nerd friends. How do you say it? It's a surrogate key. Very good. So you've got, with just that, we've already seen enough to write a join. Let's go ahead and do that. I want to say, show me every city in the entire database along with every address and every country. How do I do that? We know enough right now to do that. Let's do select star, and then we'll go back and explain why that's a really bad idea. From country. Okay, it doesn't matter where you start, but to make things simpler to write, it's often a good idea to start on one edge of your relationship. So we can either start at address, city, or country. And Scott suggested we start with country, so let's do it. Here's a quick way to pull this into your query. Drag and drop it. Country. Now, when you're writing aliases, the whole point of an alias is that it's shorter to type. So don't name your alias something like, this is the country in our query. You can do that. That is valid. Please don't do that. And the as keyword, it's optional. I'll just show it to you. Let's write a badly formatted join query. So country, inner join. What are we joining country to? Let's take a look at our tables again. So we got country, that's the top level. I think it was city, wasn't it? Yep, there's a country foreign key, country ID. So let's join city. We're going to make this painful. Ah, look what it did there. There is no ID because the paradigm in this database, and let's hope they're consistent, even in country, the primary key is named country ID. So I normally do with just ID on the table for a primary key. They call theirs written out country ID. No problem. Now we understand. We won't make that mistake again. So country ID, and I can't bear to do that, so let's call it Y. That's way too much typing. Okay, so right now, is that going to work? It's going to work, but we're not done yet. So let me run that. I pressed F5. It selects star from multiple tables. So it's going to list them in the order in which you write the query tables. So country ID, country, last update came from country. City ID, city, country ID, and last update came from city. That's what the select star is going to give you. Obviously, that's more information than we need, but we're just doing diagnostic queries, so that's fine. Here is something that I think was glossed over that you need to understand because this is the real world and how things work. It's not often you stop joining at 2 tables. You often have 10 tables you're going to join. But the good news, you only join 1 at a time. So the way to think about this, I've joined country and I've joined city and I've got this virtual result set that looks like this. I'm going to take that as like a table in itself, everything to that point, and I'm going to join it to the next bit. You have all of the columns at your disposal right here, as we see on the screen here. So I could use country ID, country, city ID, city, any of these. Which ones do I need to get to address? Let's go take a look at our table structure. Looks like we have a city ID foreign key. So we're going to use city ID. What are we going to link it to? So it's called address, I think. Yep. But how do we join it? And, well, first we have to say inner join. Address A on. If I said as A, is there any difference in that? Absolutely none. If I don't have to type it, I usually don't. So as A on, how do we join address to the rest of the query? I'm going to run that. And what do you know? We have a few more columns that came from address, starting there. So we have a 3-table join. It's that simple. If you can do a 3-table join, you can do a 20-table join. Because all we're going to do is, if we want to join to, let's see if there's anything else we can do with address. There isn't really. Maybe there's a staff that has an address. Yes, staff. So staff is a parent or a child of address. Child, because it has a foreign key reference to it. So let's join it. How do we join it? Let's take a look at the table structure. Has an address ID. Does it matter which column you specify in the equals? Absolutely not. You just type it however you want. As long as one column is equal to the other, it doesn't matter. There's another one. Okay. So you get how this is working. The way this works, the way you read this is, first table, I'm going to join it to the second table on that. That's how I'm going to make the linkage. After you have that done, okay, all of that interjoined to something else. So everything I've got highlighted there, that's the way you think about it. All of that's already joined. I've got all those fields. Now, how do I link it to the next piece? Okay, I'm going to link to the next piece on that. So this T could have referenced anything that came before it. Could have been anything in city, could have been anything in country. After I join this, I've got even more columns. So now I've got 3 tables. How do I join the 4th? You've got those 3 go together. I'm going to join one of those columns usually to the next thing. So I've got staff. How does staff relate to all this other mess? Address ID. So you can reference any of the columns up here to the next one. So if I run this, this is going to give me, oh, look what happened there. Is that wrong? That's right. There is a caveat that I needed to go over that was glossed over. When you do an inner join, what does the rule state? What are you really doing with an inner join? You're taking 2 tables, and you're relating them through a column on this table, one or more columns on this table, and one or more columns on this table. What is the rule for putting them together?
Where they match.
You must have a match in both tables. In the Venn diagram, it's the thing that's highlighted that is the intersection. So, what is this telling me? It's saying that one of these joins found only 2 matches, 2 row matches. And let me highlight just the first 3 without the 4th. And this is how you diagnose your queries. I can highlight just the first 3, press F5, and I've got 603. So we know from that, what is that telling us?
Join on staff.
Tell it to me in English.
We have a problem on line 4.
There's a problem on line 4, but specifically, it's actually not a problem. It's maybe that's what we wanted. What is it telling us? When we have 603 rows, when we join country, city, and address, but if we join staff to the rest of it, we get 2. In English, that means that there are only 2 staff that have a valid address. That's all it means. Maybe that's what we want. Maybe not. If you want to have all the addresses, whether or not a staff actually has a residence in the address list, you do it without that last one. Now,
Would that be
go ahead.
a left outer join?
Ah. Scott says, well, we know how to do that, kind of. Couldn't we do a left join? And that way, what is in English? Once again, it's very important you understand how to express yourself in English, because to be able to speak between SQL and English, you got to talk with people and explain what data you're giving them. And when they give you the specs, they're going to be speaking in English and business problems. They're not going to tell you anything about joins.
So this is saying I want where staff and address are alike, and then everything else that's in staff, or that's in address as well, since that's the one on the left.
Not just address. Remember, whenever you're doing joins, we're saying up to that point in time,
Everything from
everything. So it builds on itself. So up to that last join, we've got country, city, and address all joined together. Then treat that as one virtual table. Then we say, oh, left join. What does left join mean? Everything to the left of me, I'm going to bring that back no matter what. Not even going to look at it. It's like, take it all. If you found something that matches over here on the right, bring it along too. Now let's see what this looks like, because it's very important. This took me like weeks and weeks of writing my own queries to figure out what are the shapes of the results looking like to understand what's going on here. And I'm trying to impart that to you in like 15 minutes. So if you're going to get this, you have to pay attention. What have we got? So let's take a look at country, city, and address. The results are going to come back to right there. That is the last column in address. Everything from here over, starting with staff ID, comes from staff. Now look at all this stuff. That looks pretty scary. I don't remember having so many nulls in our tables. Did you? That's what a left join does. That's what outer joins do. By the way, I said left join. That's because I don't like to type. There's only one type of left join. It's always an outer join. So I don't have to write outer. So left join, and I'm going to show you that you don't even have to remember a right join, because I'm going to rewrite this and it'll be a right join in just a second. So what have we got here? We said inner join country, city, and address. So everything to that up to here, it's pretty simple. You've got to have a matching column. After that, it says, I'm going to keep everything from here over to the left, no matter if they match anything on the right or not. What are we trying to match on? Address ID. So this address, 3 and 4, let's go back over here. Try to find where in this list, 3 and 4, address ID. So it said, I've got a 3. I'm going to go pick up this record over here and add it to your results. What does it mean when everything over here is null?
It doesn't have a value, absence of value.
It's the absence of value. So specifically for this row, the one I've got highlighted, what exactly is going on there?
That staff member did not give any information like that.
It's saying there are no staff records that have an address ID of 2. It went and tried to find it, and it didn't find any. How does it say there aren't any? It gives you a null back.
This is like saying that address has no staff.
It's exactly like saying that address doesn't have any staff associated. You need to understand that. What happens if there are two staff with the same address? I'm going to do that just to throw you for a loop, because this is how you understand how a left and a right join work. While I'm doing this, go ahead and noodle on how you're going to get that out. Lots of different fields. Okay. Staff ID. Let's see if that's... but let me do it without the designer. There's system store procedures for pretty much everything, and I'm not going to get into it because you probably don't care to know, but I'm looking up to see if that's an identity field, and it is. Identity, seed 1, increment 1. That's identity 1, 1. That's how you say that.
So you don't want to touch it?
So that's exactly why I looked it up. Do I have to pass staff ID, or can I leave it off? I leave it off. Address ID, you know, I think we had, let's see what we had here. We already had an address for 4. So I don't like the idea of living with John Stevens, whoever he is, but I'm going to be at the same address. So say you got a friend that's sleeping on your couch. They got the same address for a while. So picture is null, email. And store ID, I'll be at the same store. Active. Okay, I put myself in as a staff. And now, we're going to do a left join. Any wagers on how it's going to come out now? I put myself in as a staff as I share the address with John.
Can we look at the diagram so we can see the relationship?
Okay, you want to see the diagram? Let's go do that. So what I often do is just select them all. And for some reason, whoever wrote this code, I think they gave it to their newbie. It's like, okay, because it takes like a minute to load. And it's not doing a whole lot. So, okay. So it's hard to see, especially because I've got a resolution of like 200 pixels by 50 pixels. But
I think you could use that thing in the top or the bottom right corner to help you with a little.
yeah. So we've got a staff, and we've got, let me see if I can do full screen.
Address, city, store.
You go to file.
And it looks like.
Actually, yeah, tell me where you want to go, and I'll try to zoom it in there.
So we're asking about a left outer join from staff to
Address. So you want to look at that properties?
which is saying that is the key indicating that that's the child or the parent in this? I guess it'd be the child, right?
So it's specifying both the primary and the foreign key. In this case, you have address.address ID is the primary key, and staff.address ID is the foreign key to it.
Okay, so address is the parent.
Yes, address is the parent here.
Right.
Staff would be the child. So there's really nothing weird about the join. It's, you know, it's like we've drawn up on the board. It's like one to many. But the nuance here is how does SQL deal with it? So you're not going to find your answer here because you already know the relationship, staff to address. That's it. So I let you go down that rabbit hole because you need to understand how SQL is going to interpret the relationship. So let's run it and let's see what's going on here. It brought me back, but what did it do to my results over here? That address, 4, is listed twice. Got to be careful. You've introduced duplicates into your results with a simple left join. And you wouldn't even expect it of a left join. Maybe an inner join because it's got a match, but a left join will do it too. Because the left join says, try to match. Oh, it found a match. It found multiple matches. This is where you got to turn off your row by row logic and turn on your set logic. Multiple rows, matches 1 here. Well, how do you represent it? Copy it. It's going to create duplicates. If you don't have a row here, you're going to have this in a left join or an outer join. How do you show this row without showing this bit? Fill this with nulls. That's just how SQL works. And it takes a while to grasp, but this is why we're doing the practice here. So we've got 2 rows here. If I had another person, say Paul coming over from the UK, he's also going to crash on John's couch. I hope there's a big couch there.
It's a super set.
It's a super slow. Yeah, hopefully it's a sectional. So what's going to happen then? I'm going to insert Paul there. I'm going to have triplicate. It's going to copy and paste that. It's going to look like it's copy paste. In the table, is it really duplicated? No, it's only there one time. But that's the power of SQL. You can make it look however you want with the joins. This is just how joins work. If it matches multiple times, it's going to show up multiple times in your result set. Unless we've learned about 2 ways to eliminate duplicates. Distinct is one, and it wasn't clear probably, but group by. Group by also eliminates duplicates across whatever fields you want. So let's actually, select star is not often what you do in the real world. Most of the time I want to answer a question. And that question is, what people have more than one address? What staff have more than one address? I want to have my name and John's name in the list.
Select staff.
So let's just get the staff name. That's a good place to start. So star, by the way, star gives you all the columns. Is that wasteful? Absolutely. It's wasteful for the database engine to pull back all those column values, but it's also wasteful. Think about the big picture. I'm going to draw a little bit. Hopefully, Richmond, could somebody monitor the Slack channel and let me know if Richmond starts screaming because they can't see this? This is...
Increase your camera.
What's that?
You should increase the camera before they tell you.
Oh, yeah. Okay. That should be good enough. So, we're talking about the database. By the way, if you're ever making nice, pretty diagrams for executives, that's the symbol for a database. It's like a cylinder that's up like that. It's like a little tin can without a label. So you can actually call our nice database. Then you have an application tier. So this is like, we're going to do some C# later on. So C#, that's your ASP.NET MVC app. And then you've got a web browser, HTML, CSS. Okay. Now, if we write select star queries here, what are the ramifications? So we say select star from 3 tables, we pull back 20 different columns, and all the data comes with it. These are the 3 logical tiers. Once again, we're talking technical stuff that you can use in an interview. A tier of an application is a logical piece of an application, a component. So this is the database tier, T-I-E-R. The application tier, or services tier. And this is the presentation tier. So if we're lazy on our database side and our C# application needs, I just want to know which staff has more than one which staff share an address. Okay? Or show me all addresses that have more than one staff at them. We're going to write a query. We're going to either save it here as a stored procedure, or we're going to write it here, and it's going to query. So there is an interaction. There's a conversation that goes on there that we're going to learn about in about a week. There is also a conversation that goes between here and here. What does that conversation look like? You've actually done that. You've done that line. You just don't know it.
Is that a form? Is it?
What's that?
Is that a form?
A form post is one example of this. There are verbs that go across from the browser to the server. What are the verbs?
Get.
HTTP verbs: get, post, put, delete. You know that. You've already done this. So what is the technology you use in the browser to talk with your application server? jQuery, $.ajax. You know this stuff. You just didn't realize it in context. So you've built the entire front end. You've talked with the server side. The server side talks to the database side. So there are 3 tiers usually at least. So we've done that. We've done that. We haven't done that. You're going to. We're doing this right now. So if we do select star here, and we say, here are 25 columns because I can't be bothered to type in 2 column names. You take a block of data. Think of a block of data as like a rectangle. This is 2 columns. And this is 20. You can send this down, or you can send this down. Which do you think is going to be faster across the internet?
The second one.
Okay, thanks, Kirsty. So this is a lot wider. And you may gloss over it because today programming is relatively easy. But back in the days where you actually had to think about the sizes of your fields, there was a Y2K problem. You know why there's a Y2K problem?
The date.
The century.
Because developers were concerned about saving 2 more characters, 2 more bytes of data to have the century in it. Oh, we'll never need to know it was in the year 2000 or in the century of 19 or 2000. Well, it bit them because now all of a sudden if you have a 23, like the year is 23, is that 1923 or 2023? I don't know. Depends on the context. So the year 2000 problem was, oh, we've got to go back and change all of those code and all of those databases and put 2 more characters on it. I did some of that. That was some of my first projects. It was painfully tedious. So the point here is that it does matter. Back then, we used to think about how big is my data? What is my data shape? Because it was a lot more important to get your performance right. Because if it wasn't right, things just wouldn't run. Nowadays, things are so fast that it's easy to be lazy. It's easy to just throw data at your middle tier and throw data at your front end tier, and it is wasteful. It's like, you look at some of the queries, you're sending 10 times more data than you need. Where is the multiplied factor of performance in? Number 1, select star in your database engine. Before we even leave that tier, if you're querying this versus this, you're going to have a much harder time. The database engine has a much harder time of getting the data you need, number 1. You get it back. It eventually comes back in a split second, 2 seconds. You send it over here. That's usually across the internet. Okay. So if you have, say, a crimp in the wire, or your internet connectivity is a little bit slower than it should be, slow everything down. You got to wait for the whole result set to get over there. Oh, if the C# developer was lazy and it's like, just send back the results to jQuery. Do it again. Except now you're not even talking about some fiber line inside of a data center. You're talking about that poor guy in a cruise ship in the middle of the Atlantic, and you're sending it over the satellite feed. All because of why? Because you couldn't be bothered to type 2 column names in your select statement. Don't use select star.
No, what I was going to say was the guy in the ocean with the site connection.
Yes.
That's what I was thinking about it.
That's this line right here. Because that jQuery from his browser on that cruise ship's little windowed place. I've never been on a cruise ship, but I imagine they have a little windowed place for the people who have to work a little bit. So other people can point at him and laugh. So he's in there, and he's like, oh my goodness, if they'd only used select first name, comma, last name instead of select star, he'd be out of there in 5 minutes rather than 30 minutes. Okay.
No problem.
So that's the big picture of why we care about performance in the database. Short answer is, whatever sins you make on the database are multiplied. That's why get your database stuff right, and then you're going to be a whole lot better off for the rest of your application. And let's make this small again. Okay, back to SQL. So you all understand, actually I want somebody in Richmond to confirm this as well as Winston-Salem. Do you all understand how to do multi-table joins? If not, let's pause and let's make sure you understand that.
I was starting from going over again.
I didn't hear. What's that?
I said I was happy from going over it again.
You want to see it again?
Sure.
Okay. Think of it as daisy chaining. So what we're doing is, I have, you're not supposed to do this with the power adapters, but you can plug one into the wall and you plug another power adapter into that. Think of it as that. That's like a multi-table join.
Oh, yeah.
Don't ever do that, by the way. If you burn down your house, it's not my fault. So, for simplicity, let's put this back to an inner. Does everyone understand why that comes back with now only 3 records? Somebody explain to me in English why it comes back with 3 records.
Because it's capturing everything that's the same over 3 different tables.
4 different tables, actually. So Stevenson's talking, he said, because it's found matches in country ID between city country ID and country.country ID. And it's found an exact match on city ID and address and city ID in city. And it's found an exact match in address ID in staff. How do I know it's from staff? Because of that S dot. And the address ID in address. It eliminated everything else. But it added a duplicate here. Why is there a duplicate for Lilydale Drive, where apparently I live now? There's 2 people living there. 2 address IDs match. So it has to give you the truth. Think about it like that. SQL's got to tell you the truth to the result of your inquiry. How does it do that? Sometimes it's got to duplicate records. Sometimes it's got to show you nulls. So let's do another one. Let's use let's switch gears. Film actor. Let's see if we have any records in there. Yeah. So actually, what kind of table is this? You know relationships. What kind of table is this?
That's the child table. Those one, 2 different.
It's a child table. Not you. It's what?
It's a many-to-many.
It's a many-to-many. This is the cross-reference table or the junction table in a many-to-many.
That's what I was trying to figure out.
Yeah, because we've got an actor ID. So actor is a foreign key. Film ID is a foreign key. What do you think the names of the primary key tables are? Probably actor and film. You see, now that you understand one-to-many and many-to-many, you can read almost any relational database in the world. It's not that complicated. The complicated stuff comes in SQL, which is what we're going over. So we can take a glance at this, like, oh, I see what's going on here. Let's query. If we wanted to answer, show me a list of all films and all actors in those films. How do we start a query? Let's do the easy start part first. Select. Now, oftentimes during writing the query, I'll just do a select star. But always before you finish it, before you put it into your code, and before you create a store procedure, get rid of that star. And you know why now. For now, just because I want to see everything, just do star. So select star. What's the next thing? From. So always part of a select. Select, column list. From. Now, column list, that's your width of your results. If you don't specify a where, it's the number of rows, all of the rows that match. If you want to limit the rows, that's your where clause. So select projection, where. So select from, we got 3 tables here. Do we want to have, what type of join do we want? Does it have to match? Oh, by the way, I was going to go back here and show you. I don't think, I didn't delete it. Get rid of that. So I was going to show you the right join. Why do I not care about right joins? Why don't I give them the props? Because, hold on, I'll show you the equivalent query. It's all about how you think. If I say this, so the top one was before. Right join. And I've got to rearrange everything. So the address goes to city. Yeah, after you write it one way, it's a pain to have to write it the other way. We're going to do it just because I think you're going to get something out of it. And you probably never again use a right join. City, T. Okay. Identical results. What am I doing here? And this actually relates to Aaron's request to actually see it a couple more times. So, inner, we got two tables joined. Look at your results. So we can actually highlight in SQL Server Management Studio just that and get the results. You see how it's going to run that query. It's valid. Next line, join another table. We got more columns here. Finally, left join, more columns. I want you to see that this is identical to this. The difference is, let me put parens around this. So, paren from there to there. And right join, that same thing down here. So what you're doing is, when you're writing a join condition, you're only comparing the thing on the left and the thing on the right. So if you're saying thing on the left, right join, it depends on how you write it. So staff is on the left, right join. And you're always pointing to, the word points to the side that you want to keep. So on the board, Venn diagram. Yeah, I gotta do the camera thing again. Venn diagram. What is that? What type of join? That's an inner. Because you only care about the intersection. Say right and left. If I'm doing a left join, you want the match and everything on the left. Leave off the right. If you're doing a right join, give me everything on the right and the intersection. Leave off the left. Now, keep that in mind. Let's take a look at the syntax. Exactly what does that look like in code? This is what it looks like in code. You say the two circles, the left part of the circle is this, and you're saying left join. So you're saying those three table joins, country, city, and address, treat that as one virtual result set. That whole thing is my left circle. So bring all of that back, no matter what. Don't even inspect it. Just get that and give it to me. Now, left says bring it all back. That means whatever's on the right, I'm going to pull it back only if it matches. That's the intersection. But if it doesn't match, you're going to leave it off. Same thing here, right join. It's all in how you write it. That's why very few people actually use right joins. They just getting used to, I'm going to do my left joins. And it's exactly the same thing. So in this case, we're saying it's how you write it. The thing on the left, we're only going to pull that back if it matches the intersection. The right says right join, bring all that back no matter what. So it's exactly the same thing as the Venn diagram except the different circle. And because it's a different circle we're bringing back all the time, we have to actually say left or right plus the intersection. You might ask yourself, is there one that pulls back the intersection and the left and the right? Yes, and I've used it like 3 times ever because it's so rare. It's called a full outer join. Nobody ever used it. I'm not even going to go over it, okay? If you ever need to do something like that, it brings you back the intersection, and it brings you back, I'll explain what it would bring you back. You saw how in this query, we got a bunch of nulls, right? We got a bunch of nulls wherever there was stuff over here, there was an address, but there was nobody in there. There was no address staff person, right? You'd get this exact result set back, except on both sides. So you actually write it like that. In this case, it doesn't make any sense. But say you had staff that had an address that did match on the other side. In that case, you would pull back the staff and have nulls on the left-hand side too. It's, like I said, you never use this. It's left joins and it's inner joins. Learn those, you're good. In the very rare case that you'd ever, and I actually use this because, oh, I've never used that. Let me see if I can find a weird use case to find how to use that. And I had to force myself to use it just to see how it worked. It was lackluster, okay? Nothing to it. So, left join. You need to understand how this works. Let's go back and see it in a different way. So I asked for, give me all actors and all films in the database. So we have 3 tables. We have film, we have film actor, and we have actor. So how do we relate them? We've got to join them, yeah. So how are we going to join them? Let's take a look at the columns. Help me out, guys. You've seen this a few times. What's that? Film ID? What's the syntax? Okay, so we got 1. How do you know it's right? Just highlight and try it. Yeah, it looks right. Well, it looks like Academy Dinosaur has a lot of people in it. As far as we know right now, that's right. Yep, look, there's film, lots of actors in it. Okay. So there we have it. Now that's not something I'd want to send down my jQuery. How do you get this down to something that we care about? What's that?
Now we use your where.
Where is going to filter the rows, but really all we want to do is show fewer columns. So we might get to the where in just a minute, but for now let's reduce the number of columns so we can make more sense of this. So when we talk about a film, in English, how do we normally refer to a film?
Movie?
Okay, let's call it a movie. And let's give it just a name, you know? So let's see if there's a name column. There's a title and there's a description. Let's use the title. So how do I give a column an alias? And how do I say I want the title column of the film table?
You put the alias in brackets.
Alias dot JSON style. Just coincidence that it works the same way. F dot title as, you want to call it movie, right? Mm-hmm. Movie. That's it. Name it whatever you want. Now if I run that, we got the movie name, but it doesn't make a whole lot of sense because we joined other things and we're not showing any of the fields from them. So it's not just, we don't care about the film actor to display because remember what the film actor looks like? Let's take a peek. That's more for consumption by computers rather than it is for people. It's just dates and numbers. That doesn't make a bit of sense. That has nothing to do with the movie, right? Nobody wants to see that. Don't show it to us. What do people want to see? I said, show me all the actors in all the movies.
Want to see the names of the movie and the names of the actors.
Exactly. We want to see the names of the actors. We want to see the name of the movie and take away all that other nonsense because it's just noise. So let's go look at actor. We got a first and last name. That's going to do. But I don't want to see first and last name. I just want to see the actor's name, for goodness sake. How do I do that? Well, let's step one at a time. So first name and last name, we can do that, right? Let's do that and see if we got what we want. That looks good. It might look right. It looks like Penelope Guinness, whoever she was, in a lot of movies. I guess she's the Kevin Bacon of this database. So first name, last name. We want to put those together because people in the real world don't care about seeing things separately. We do that because we might one day want to have just the last name. How do you concatenate? Plus works, but this also works. This is slightly better because this will work on any relational database platform. This is the ANSI SQL standard way of doing it. In Oracle, how do they like to do it? I don't know why they like to do that, but their concatenation in SQL is the or statement from other languages. Like, don't do that. You're just screwing with people. That's how they concatenate.
So this is running select the title, what we're calling the title of the movie. The first name, the last name, that's the actor's name, and then it runs from the film table, film actor table, film ID table.
So Ryan is walking us through what's the sequence of events that happens.
So it's joining these tables together, but it's pulling first name and last name from all the tables.
This is where set logic comes in once again. Don't try to figure out the sequence of steps that SQL, the engine, processes in order to give you the results back. You have to take a step back and think like a mathematic PhD type person is like, okay, how am I going to overlap these things, and how do I visually see that? So
Well, that wasn't what I was asking. Actually, I was just
think about the rows and how they match.
That's being pulled from.
Don't look at your select first. Select is your dessert. You do that at the end. Strangely enough, it comes first, but you think about it last. What's most important is think about the tables and the relationships that you need to get the data from. Get your set logic down. Understand how film and film actor relate. Understand how actor relates to film actor. And when you put them all together, what types of joins did you use? Do you have to have a match, or is it optional? These are all inner joins. They have to match. Once you have that, as a matter of fact, this is always how, I shouldn't say always because I never do something consistently. Select star. I first look at, here are all the options. And then I'm like a kid in the candy store. I went that column and that column and that column. But then it's a matter of, what do I want? Well, let's think about what the users want to see. I'm going to give them back movies and actors. That's probably not good enough because we got some demanding users and they want to see it listed by movie order. Let me show you a trick. Order by, right? And normally you'd have to specify, how would you say that properly? F.title. And it might be nice, you can have multiple columns sorted, so let's run this first. So Academy Dinosaur, it's ordered, but Penelope, Christian comes before Penelope. So how do you have a secondary sort? Just a comma. A dot first name, and you have to say this whole thing again. Now it's going to be ordered first by movie, and then within movie, it's going to order, so look from here to here, it's going to say, order the actors underneath the movie. It's a secondary sort. What's that?
Is that how you get the credits at the end?
I couldn't tell you. I don't know. The question was, is that why the credits come at the end of the movie? It's like, I don't know. I don't make movies. So here's a shorthand. And this, I'm going to comment this out because I'm not actually prescribing you do this, but you will see it. What do you think that does?
Orders by the actor's name.
Orders by the actor's name. You picked it up right like that. So it says the order of the columns that I have in my select. You can talk about those columns by the sequence and numbers.
Yeah, listed out too.
No. Nothing else works. Nothing else easily works in order by. You can do some nasty things in order by, but That's as crazy as you want to usually get. You can specify order by 1. That really means the first, so you don't have to write that whole thing again. Especially if you have something like this that's a calculated column, you can just say order by 2 rather than have to type that whole thing again. So the equivalent is that, order by 1, 2. 1-based sequence. Now, Aaron has been dying to use some of his where clause skills. So if we want to say, show me only movies that have the word West inside of them, somewhere, anywhere inside of them. So we have all of our rows, 5,462. Time is flying. We got to get back and let you all start writing some SQL. This is the last thing, and I'm going to actually let you go, and then we'll come back and do some grouping by and aggregates later on. So I want to say, show me only the movies that have the word West somewhere in the title.
Where, title, like, is that the right word?
Like, very good, like.
And then you would put West with the percent sign?
Well,
Right.
we have to delimit our strings with what in SQL?
Quotes.
Single quote. And then, like, we're saying West. So how do we say West anywhere in the string?
What percentage?
The wildcard is percent. That means I don't care what happens before this. And then the word West. It's not case sensitive.
And after?
If we said it like that, what would it do? Just percent West.
Anything west, southwest.
It has to end in the word West because we didn't have a wildcard on the right-hand side too. If we said it like this, that means I don't care what comes before it, and I don't care what comes after it, but you have to have the word West like that. If I said that, what does that mean?
Westward. West.
It has to start with the letters W-E-S-T, but then I don't care what happens after. Who knows what that means?
Est, isn't it?
Underscore is not like percent. It's a wildcard for one character.
So it could be best.
Best, fest, so on. So percent means any number of characters, whatever you want. Everybody's, okay, now we got zest, best, fest, yeah, I get you. So westward, let's get back to that. You can also do something like that. In square brackets, the like knows how to interpret some very basic intent. It's not as powerful as if some of you know regular expressions. If not, we'll talk about it maybe in the last week. It's a very powerful mini language that allows you to parse strings. So you can extract information out of strings. We're going to stick to, most of the time, people care about wildcards. So we're going to do this. Title. Okay. If you look down through all those movie titles, there's going to be a West somewhere in there. Okay, now, we've done inner joins, we've done multiple table joins, we've done left join, right join. What else do you all feel like you need to see, or do you want to go practice for a while? Practice? Okay. Let's review what I've asked you to do earlier on. Questions? You got too many channels. There we go. So the first one, you're going to send out, going out a business postcard to all currently active customers, and you need a unique identifier for each customer to keep track of who has been contacted, their name, and their email address. Okay. So really, this is a simple query against which table? Do we have a customers table? We do. So this is the simplest one. That's a one-table query. All we're really asking for is I don't want you to return star. I want you to return which columns you care about. The second one, you're looking for a movie to watch with your nephew. Find unique list of movies. When I say unique, what am I probably after? Either a distinct or a group by. So get rid of the duplicates, is what I'm saying. That are classified as children or comedy. Who took a crack at that one, or who has looked at that one? So children or comedy, what table are we talking about there?
Category.
There's a category. So we have to take a look at how category is related. So category, just let's right click, select top 100. There we go, children and comedy. That's what we want. Now, we got to figure out how it's related to, we're looking for movies. So the movie table in here is what? Film. So, oh, there it is. There's a film category table. That's a many-to-many junction cross-reference. So we do a 3-table join, probably home free. Start there. Go down through, and I want you to hit a roadblock and ask questions.